Okay, hello everyone. In the last class, we have been discussed in detail about equivalent focal length of two thin lenses separated by a distance t. In detail, we have been discussed. Okay, uh, and also we discussed location of cardinal points of combination of two thin lenses, and we discussed one question based upon that concept. In this class, we are going to discuss to find the thin lens formula by using system of matrix. Okay, so before we are going to start today's topic, first we have to discuss in short about system of matrix. See, about system of matrix of an optical system, uh, I discussed in lecture number 8 in detail. Okay, I suggest that before you are going to watch this video, you first watch this video, lecture number 8. In that video, I discussed in detail about system of matrix of an optical system. Here, system of matrix of an optical system is act as a operator. Okay, here you can see this is the system of matrix, multiplication of 5 matrices. When operated over input information or object information, we can find the output information or image information. This is your image, this is your object. So for whole system, here we have to consider these multiplication of these 5 matrices. But if we are going to consider particularly about of a thick lens, here this is the first refraction, and this is the translation, and this is the second refraction. Okay, refraction 2. So to find the optical to find the system matrix of an optical system for this thick lens, what we have to do, we have to multiply these matrices in this order. First we have to consider refraction 2 matrix, then translation, then refraction 1 matrix. In this order we have to multiply. Okay, so this concept you just keep in your mind, and again I suggest that you just watch lecture number 8 video. In that video I discussed in detail about system of matrix. Now consider today's topic, thin lens formula by using system of matrix. Here thin lens formula means this one. If we are going to consider this is your lens, thin lens, then thin lens formula is nothing but 1 by v minus 1 by u equal to 1 by f. Here u is the object distance, v is the image distance from the center of this lens. This is the object, so u is the object distance towards left, v is the image distance towards right, and f is the focal length of this thick lens. So this equation we are going to find out by using system of matrix. Consider this ray diagram. This is your object. From this object, here from figure it can be noticed that from object O to image I, the ray gone through two translation and one refraction matrix. So this is one translation matrix from O to A. At A one refraction happens, then from A to I up to image another translation. So here from figure it can be noticed that from O to I, the ray gone through two translation matrix and one refraction matrix. Or we have to write the system of matrix by considering two translation. This one is your one translation, this is another translation, and one refraction. Okay, now we are going to calculate the system of matrix of this ray diagram or this ray dynamics. Translation is represented by this translation, that means from O to A is represented by matrix Tm1 1 minus u 0 1. See, in general the translation matrix is nothing but 1 t by mu and 0 1. Okay, suppose may you remember that this is the translation from A to B, and this length is your t. Okay, t, and if this translation happens in a medium mu, then this is the translation matrix. Here we considered mu is 1, that means here we consider this medium is vacuum or air medium. So here mu is equal to 0, and t means this length or this length magnitude is u, but as we are taking towards left according to sign convention, we have to consider minus u. Now consider the refraction at A. The refraction corresponding refraction matrix of a thin lens is nothing but 1 0 minus 1 by f1. Already we haven't discussed in our previous class. You just watch that one. 1 0 minus 1 by f1. Here f is the focal length of this lens. Now consider translation from A to I. A to I, the translation matrix will be 1v01. Here v is the distance, the so-called image distance from the center of this lens. As we are moving towards the right, so it will be considered as plus. Now the system of matrix will be what? First we have to consider Tm2, then Rm, and then Tm1. What I just discussed here in the system of matrix. First we have to consider this one, Rm2, R2, then T, then R1. Right? Same here we use that concept. Translation 2 matrix, then refraction, then translation 1 matrix. Here I just written the values. This one 1v01, this Rm matrix written over here, this Tm1 matrix written over here. First multiply these two matrices. You can found this one 1 minus u minus 1 by f plus 1. Then we have to multiply these two matrices. Here I written once again and just multiply these two matrices and simplify. You can found Sm equal to 1 minus b by f minus u plus uv by f plus b, and this element is your minus 1 by f, this one is your u by f plus 1. Now consider the coordinates of object and image in the matrix form. It can be written as, here you can see the object information is this one, right? Object is this one. This one means for this case, for this one, here object height is not there. First you just write in general, here object information means y1 theta 1, okay, y1 theta 1, and here y2, this is theta 2, y2 theta 2. Here if I'm going to compare theta 1 and theta 2, here theta 1 is in your anti-clockwise and theta 2 along clockwise. So whenever we have to write with comparison theta 1 theta 2, then theta 1 will be negative, will be the negative sign according to sign convention with respect to theta 2. In our previous discussion we found the image coordinate can be found by operating system of matrix on the object coordinate. That means if we are going to apply or operate the system of matrix on the object, then we can find the information about or the coordinate about image. That work here we have to do. Here system of matrix, this one operated on the object information or object coordinate y1 minus theta 1. We can find the image information or image coordinate. Here you can see, here left hand side theta 2, right hand side theta 1. So comparatively theta 1 will be considered as minus according to sign convention with respect to theta 2. Okay, now y2 theta 2 will be equal to, here instead of Sm, this matrix written over here into y1 minus theta 1, right? Here y2 y1 here substituted as 0 0 because here it is a point object, there is no height, so if I'm going to consider this figure, here this object has some height, so here we can consider yi, here yo, but here we consider the it is considered that point object. That means this y2, this one, this is point image. Obviously point object means point image, so for the point object and image, this y2 and y1 value will be 0, right? Now 0 theta 2, here I just multiplied these two matrices. We can found, see, this row, this column, this row, this column means this multiplied with 0 plus this star multiplied with minus theta 1. Here a mistakenly written alpha 1, this should be theta 1. Just wait, I have to correct it. So multiplied with minus theta 1, then this row multiplied with this column, so minus 1 by f multiplied with 0 plus this one u by f plus 1 multiplied with minus theta 1. Okay, left hand side is your 0 theta 2. Just compare this row with this one, left hand side row to the right hand side row, first row, and second row with the second row. Here 0 is equal to this value, this much. Here this term will be 0 because it's multiplied with 0, and you just write these two terms here, minus u v by f plus v into minus theta 1. Let this is your equation number 1. Okay, and this second row will be equal to this much. Here this will be 0 and theta 2 will be equal to this much, written over here. Here theta 1 and theta 2, see here point object point image is there, but this theta 1 and theta 2 has significant value. It could not be 0. It could not be 0. Theta 1 could not be 0. Theta 2 could not be 0. Now consider equation 1. So to satisfy equation number 1, if theta 1 could not be 0, then this value has to 0. Minus u plus uv by f plus v should be 0. Otherwise equation, how it will be satisfied? So here to satisfy the equation number 1, this value equal to 0. So you just rearrange the terms. You can found 1 by v minus 1 by u equal to 1 by f. This is nothing but your thin lens formula. Okay, so here up to this lecture we completed up to this much. Okay, next class we are going to start to discuss Ramsden and Huygens IPS. Wait, before that we have to discuss introduction to IPS. Then we are going to next class we have to discuss Ramsden IPS. So next class we are going to discuss introduction to IPS. Okay, so thank you so much for watching this video. Thank you.